But we do appreciate Dave for sitting there. And part of the reason I want to tie this with Caesar, we work so well. And some of that, I do spend some time trying to convince pipers. We do need to do a little bit more handshaking with Caesar, coming to CAD Works, in and out. I can push a button, send it to him. I love it all day long, but that piper in me, when he just redrew that pipe, I ain't bringing it back in. He just messed up everything I had in that area. So I want to look at it first. But there's ways you can overcome that. And I do suggest, bring that thing back to your model. Really look at it there before you say what he did to it messed it up. Now, I had hopes to be able to bring in a nice, pretty machine that feeds well, because what I'm going to show you a little bit is the new CAD Works Fieldpipe. Works on top of our CAD Works and direct modeling. It's spec-driven. What this technology does, it works twofold. One is I can tie it to a total station, shoot the piping in. Other is work with the laser cloud data. And Leica unleashed a new machine in Hexagon in June. They unleashed it so well we can't find one. I found one machine in Houston, one of the dealers has it, and I was hoping to have it set up down here and show you this thing. It really shows how Fieldpipe can benefit all the pipers, and to try to get us there. I don't know, I kind of got a mixed group. He didn't think I had any Caesar engineers. How many field pipers do I have in the room? You got a tape measure in your hand and you're out there measuring pipe. Got a few. I'm one of those guys for 30 years, and I'm getting too old to do that climbing anymore. I see this software, I fall in love. I don't have to climb another ladder in my lifetime. And the only question I ask them all is, where was this 30 years ago when I got on that first ladder? A laser scanner point cloud can represent a very complex real-world condition. These guys go out, set up, and in a matter of minutes, they're collecting real-world data. These are created by the scanning devices. Leica has a number. They're sister to Intergraph, so we talk a lot about those guys. There are other platforms out there. Fortunately, with my Leica software, I can utilize those scans, bring it into my Leica stuff for Fieldpipe. But they represent real world today. And that's part of the reason also I wanted Dave here about Caesar. We're talking real world pipe. And we're going to do a lot more work with Caesar there, because when I'm doing real world scanning, real world pipe, it's hot. It does not represent the pipe back in the cold position. I think that's a strength between me and CAD Works and Caesar. So now I can take that hot model pipe, create a true life model, push to Caesar. Caesar sees it in its hot condition and bring it back to cold. That comes back to the model. Now guess what? I got my cold pipe back into the model. So between all of them handshaking together, we get back to real world, can really do an analysis and as-builting that facility. I can find my tie-ins and get them done. Fieldpipe Pro came out. We combined the best. Some of you may be aware of some of the Leica tools. Leica CAD Works for AutoCAD has been around for a number of years. This Piper a number of years ago, I twisted the president's arm of the company I was working for. He said, you had to buy this, or I'm not going back out there. We bought the software, it runs well. That's the engine driving behind Fieldpipe. We can do it in a multitude of ways. I can go to an existing facility, go to work on that facility, as-built that piping condition. I can follow that spool piece all the way back to the shop. Now I can as-built the shop-built spool piece. Did they build it per ISO and specifications we sent out? Both sides. A lot of verification tools available to you. Traditional way, manual labor. Old piper crawling a ladder with a tape measure. I got sophisticated. I had a laser level that shot a laser beam with my level, and then I'm eyeballing this piece of pipe. I'm plus or minus a 1/4 inch on a good day. Not very safe. And I guarantee, take back to your office, tell them the safety factor of you staying in that office chair where they like you. The worst that can happen to you is a paper cut. I guarantee worse can happen than that when you're on site in facility in operating conditions. Yes? I can do some of it, but the other side of that, if it's me, well, I'm standing on the ground. next to a tripod, so I'm not climbing. The other side, the big scans, I'm getting a vendor in most cases.
Do you rent the lasers out, or?
The cost of the big laser machines, now I will say the MS-50, I said I'm a big fan, I was trying to get here, is not very cost prohibitive in my estimations to some larger companies. The big scanners, the faster scanners that I'm going to use for as-builting a large area, they get quite expensive. Now you're up at $100,000 and plus range for those scanners. So those, I have service providers all over the world. Enough today that they are very competitive. So I can get very competitive quotes to go deliver me a scan back to the office, keep my pipers in the office. The other side, by total station, or as I tout my MS-50, I love that machine. Yes, that is me in the field, but me on the ground. Me several hundred feet away from the target and gathering the data with the accuracy I need. And that's in the millimeter accuracy range. Total station or scanning to get laser clouds.
On that subject, how would you compare the pricing of those bids, say, from 3 years ago?
They come down consistently. Like I said, some of it has been, and I'm going to say over the last 10 years, there has been more and more moving into the market as scanner providers, and that's their specialization. They own the equipment, they own the software to bring you a registered scan, so they've gotten very competitive. Houston area market, I could probably find you 15, 20 out there within a distance that would be competitive with each other. Scattered around the U.S., you could probably get a list of 5 consistently for any U.S. Competitively bid and get a quote for providing a big scan. I'm taking field notes. I'm writing dimensions on the paper. I can guarantee, and I won't use the terms I used then when I did, but when I got down in the chair, I started putting it in the machine, it was, uh-oh, I missed one dimension. Now it's another trip back on site, go find those dimensions I missed, bring it back in here on paper, get it into the model, now we're moving forward. 3D model with CAD Works Fieldpipe scanning or total stations, there's no forgotten dimensions. It all comes to you. Some of the requirements. You got a device and field pipe set up. This is using it, just shooting the pipe. I can use the total station device. An MS-50, so give you the equation, it's a multi-station. What it is, it's a combined total station and a low-level scanner. So it gives me best of both worlds. But I can take that machine, shoot out on that pipe, find 3 points. 5 points gives you a little bit better accuracy. But shoot those 3 points, I've found the diameter of my pipe standing on the ground. Find the center line of that pipe. Shoot out to one end, get 2 points. Again, this is a laser of a total station accuracy. 2 points to the other side. Now I'm identifying the center line of my pipe. And we're driving this with CAD Works in the background. So it's seeing my specs. It's being spec driven. From here, I'm creating a model environment in CAD Works spec driven. Now go out and start finding locations, find the backside point of the flange. Locate that into the model. Real world data here. I can now push a button, the ISO comes out the other side, we're done. With millimeter accuracy versus my tape measure that I was doing good to be within 1/4 of an inch. And that was a good day. Older I get, the bigger that gap gets. Laser scanning, what are the requirements of that? About all you really got is somebody to go out there with a scanner machine. Set that machine up, set it up in the coordinates, push a button, go sit down. Now it just takes a few minutes. The MS-50, to give you an idea, and I equate this by a configuration we practiced with a few weeks ago here in this room, an average pump suction line with an MS-50 would take about 10 minutes of scanning time. And it'd be 100% scanned, all the pipe, all the connections. The big scanners, that same pump suction line would have been about 5 seconds. So the bigger scanners are collecting more data faster.
What about if you have insulation on the pipe? Oftentimes the insulation is not around and everything. How does that relate to the center of the pipe?
That's the good thing. I like my CAD Works guys a lot of days. There's some of them over here know the days I don't like them, but they built in a tool in CAD Works Fieldpipe. I can tell it my insulation thickness for the pipe I'm working. So it does put a little bit back, and I'm going to tell them all. Some of them think I'm getting rid of the pipers. I still need pipers to drive all of these tools. I need to read the P&ID, know what my insulation thickness is, and I need to know what lines I'm looking at so I know the spec. So once I've set those two parameters, it'll auto-correct down for what it sees diameter of insulation down to real pipe from the scan. So like I said, my intergraph guys looked after us a little bit there to do that calculation, get the diameter back out.
Mike, has there ever been concern about cladding and not showing the true center line? If insulated pipe doesn't reflect the true center line?
I have some concerns about that, but I'm looking over the long run of the pipe. I'm going to develop an average, and to some extent, that's what the software is looking at. When it's developing the scanned center line, it's looking at an average over the entire distance. So if there is, and yes, there are spots somebody was standing on the insulation, crushed it, and changed the physical features of it, you'll get a little bit of that. But I think on an average, you'll see a true center line. Biggest thing to me is the off-site cleanup of that point cloud. That machine collected the data, sent it to the office, I cleaned it up, and I go to work, start cleaning it up, create a 3D model. I said, my big safety factor to me, keep the pipers in the office, in the chair where they belong. At worst case, send him out there with a total station, keep his feet on the ground. Safety number one, and every company I worked for, the biggest thing they could say, if I hollered safety, they listened. Laser survey or laser scanning, all of that's point to point. Again, very accurate. Laser surveys with 2 to 3 millimeters, laser scanning 4 to 6 millimeters. Some of that based over distance and different factors. But the machines are very accurate. I can guarantee you I have not met a piper yet in my 30 years that could pull a tape any tighter than this is. Laser survey, I am in the plant. I am behind the machine. I'm pointing and shooting. Scanning, I stay in the office. I'm hiring that outside contractor. Go get it, bring it to me. Classic example for me, I performed a project. So, you know, I'm a real world piper, except I got to jump and go play with software a couple of years ago. I joined PDS about 2 years ago now, this August. Got to play with software, get to play a little bit, look at this. But I bought CAD Works for AutoCAD 6 years ago with my last company. Performed a job up in Oregon. Nobody ever went to Oregon. The survey crew went to Oregon, set the machines on the ground, brought it back in. We went to work, and we had 0 dimensional errors on fabrication. That sold me. Worked with a few larger companies around town. I won't give the names on those. I know what they tout to me in using laser scanning technology in the design process. Their error rates are under 1%. The old school methods, we were 10, 15, 20% error rates. And I know the first one they fussed at, and that was me sitting in a chair over there. Why didn't you get it better? And when you're hanging like a monkey off a pipe rack, you get what you get. This is kind of a little bit of an investment comparisons here. And some of it is, if I'm going to do it all, yes. 10 to 35,000, or you go to the MS-50, so I don't scare everybody. That is about a $50,000 machine. Other side, go to scanning. Yeah, it goes up to, actually probably get up to closer to $150,000 investment. It's worth spending a few $1,000s a day for somebody else to do that and let them spend the 150 grand. Both give you the same thing. I walk out, I got a 3D model, I got my ISOs and all my build materials in millimeters of accuracy. They got to put it out there. Best option for small projects. I think best option both ways, combination of the two. And since I've talked about the big boy toys, you know how pipers are with toys. Well, somebody brought me one of those toys. We kind of unveiled this in Vegas ourselves. Price points you saw back there. Here is a handheld laser scanner. Came to market this year. Not quite as accurate this. It has some limitations. I feel like it's a good add to every Leica machine they've got out there. I can walk out in the plant, scan a pipe in a few minutes, bring it in, and I've got accuracy levels I can't pull a tape to. Yes, it's nothing more than a little tablet with software. To be honest with you, that camera on the back side, your kid's probably got that tied to his video game. It's Connect Camera. It's really what it is. The software inside running it's a little bit different, but that machine and that setup's $5,000. It will feed the same data into our software. I can bring that into CAD Works Fieldpipe and go to modeling. So as I said, pipers get all the cool toys. Structural guys still fuss at me because they don't get anything to play with. Give you a view. This is CAD Works plant. CAD Works users here? Few? Good. What you see isn't any different what you're working on today. It's just added on with some field pipe tools. It's got another little piece to it. That allows me, and part of this is I have like a cyclone engine driving behind it to allow me to go out and find a point cloud. Get down to it. This is a larger scan. We've worked it down a little bit. You'll notice here I'm bringing it in. I've set the parameters. I'm going to work in inches. I've got it set to a plant coordinate system, so I want it to come in on a plant coordinate system. So once I hit OK, let it zoom out to go find it. And yes, it does take AutoCAD a few minutes to go load this thing. And something for you to realize here. What you're seeing here, that is millions of points of information from a survey level instrument. There is X, Y, and Z coordinates based off a survey instrument in each one of those little bitty dots. And there's millions and millions of them in here. Any of you worked much with laser clouds? You find the cloud itself sometimes hard to work in, hard to see everything I'm going to look at. I'm going to show you some magic that they gave to us here. Are you familiar with the Leica products of TrueSpace, TrueView? A few nods of the head. We actually work with that a bit. So I can go out to my key plan, which was built as part of the survey. And let me position these in the right areas. Basically what I've done, I have linked TrueSpace to CAD Works. And refresh that. Get it to look around a little bit. Now if you notice, I'm looking at TrueSpace on the right-hand side, and I'm live in the model in the audio side. I got the best of both worlds now. I've got a true picture quality in the right hand that I can read, see pipe, go to work on it, spin it around, and it keeps me live to CAD Works. If I want to move around, go to different viewports. If you notice, I'm staying live. When I move around in the TrueSpace, it keeps me here. The cool part. I love developers when they give me cool parts here. Is by selecting this, and I'll go to the CAD Works Fieldpipe palette. Again, Us old CAD Works users, we got to get used to pallets and ribbons and things of that nature instead of toolbars. This is pallet driven. Show you a few things on it. I've got tolerances I can set to it. I can set this, set it to a spec, which I do need to do. I need to drive this based off a pipe spec. And I'm just going to pick any size. It doesn't really matter. So now it's set up, and you'll notice here is my insulation calculator. Now I can just go to the field, find that number for my insulation. Now, it's piper got to drive it. I got to go PID. That pipe's insulated. It's half insulation. Plug it in here. So when the system calculates the pipe OD, it'll factor out the insulation thickness for me. Thank goodness, one calculator, I don't have to do anything. It does it for me. So from that, now I can start selecting components for pipe. And I'm sure some of you have worked in some of the point clouds. You do all of that inside the point cloud, kind of get the center line, work this, get this, fit model components to it. Well, now I'm going to go to TrueSpace, tell it I want to draw that pipe and this pipe, and it'll put it in the model for me by just setting it up, getting it ready to run. Select my pipe in TrueSpace. And if you'll notice in the model side, it just centered up and laid over a nice piece of pipe for me. Can't quite see it in the model side, but I can see that in TrueSpace. There's my vertical piece of pipe. Switch it around enough, go find more of it, get back on center, find that top level piece of pipe, now you notice in the model I've got real world pipe. That's how hard it was. Look at a picture, point, and shoot. Can I make it any simpler? That's the good thing. Some of them asked me, and they even asked me about the MS-50. I sat here and I ran the machine that day. He took me through it a little bit. He said, he asked me, what do I think of the machine? I said, man, I can teach any piper how to run this machine. We are a little hard to teach new tricks, but we do catch on. This is a very simple process. And what I've done, as you saw, I set it up pure pipe spec, so it's written in a CAD Works spec. Time I come out of here, we're ready to run ISOs. You're in as-built conditions. Again, as I mentioned, I liked having Caesar here with me to kind of get both worlds. True, when I scan this, your plant is hot. So if you're in a unit, and I will advise this as working pipers, you're in a unit that's got high temperature ranges on the piping systems, you want to take that into account. I'm going into a coker, I'm scanning, I got a lot of hot pipe. When they shut it down and I go to work putting new pipe in, it moved inches from where I scanned this thing. I believe that's where Caesar will come in and be your tool to come in up front, design that system, and find the cold positions for you to go back in and fit that as built. I'll get fewer phone calls from management because they're in a fight with the owner because they want to charge back for all the field rework with this tool. Any questions?